So in Unit 3, we also look at just a very little part of Chapter 13, which covers sensory receptors in the skin. So in the supplemental folder, I've also included a chart that you can fill out to help organize these receptors. Okay, the information in this video is going to be very straightforward. Is the receptor encapsulated or unencapsulated, and what is it detecting? Okay, so that's the information you want to know about each type of receptor. There are 7 receptors, so let's go through them. Okay, so we're looking at tactile receptors, the receptors that are going to detect touch sensation. Okay, so this is the most common type of sensory receptor. They're located throughout our skin and mucous membranes, and mechanoreceptors are going to respond to touch, pressure, vibration, and stretch. Okay, so we can classify these receptors as either encapsulated or unencapsulated. And that is just talking about whether the terminal ending is wrapped in connective tissue or not. Okay, so if it's encapsulated, it's going to be wrapped in this protective connective tissue, and if it's unencapsulated, it is not. Okay, so unencapsulated, let's just draw our receptor here. Okay, so here's our receptor, and encapsulated, we're going to have the receptor, okay, and it's going to be wrapped in connective tissue. All right, so we have 7 total receptors, 3 unencapsulated. Okay, so free nerve endings, root hair plexus, and Merkel disc, or Merkel cells, which we saw as one of the cells of stratum basale. So Merkel cells are tactile cells. Then encapsulated are the remaining 4, so end bulbs or Krauss bulbs, Pacinian corpuscles, Ruffini corpuscle, and Meissner's corpuscle. Okay, so our first tactile receptor is just a free nerve ending. Okay, so this is going to be closest to the surface of the skin. Okay, and this is the least complex receptor. Remember, this is unencapsulated, so we don't have a connective tissue wrapping. Okay, so let's look right over here. We can see our free nerve endings, and these are going to be responsible in detecting temperature and pain. Okay, so moving on, we have our root hair plexus. So this is a nerve plexus around the root of the hair. It forms a sheath around the follicle. So if we look down here, we can see this network of nerves around the hair follicle. Okay, so this is going to initiate a nerve signal when there's displacement of hair. Okay, but we're going to acclimate to this at a very rapid pace. So think about, right, when you put your coat on, you can feel the hairs moving, right? You feel the displacement of your arm hair. But as that coat or garment stays on you, right, you don't continuously feel that sensation until you take the coat off again and the hair is displaced again. Okay, so again, unencapsulated and detecting the displacement of hair. Our third unencapsulated receptor is a Merkel cell. Okay, so remember, Merkel cells are one of the 3 cells in stratum basale. We also have keratinocytes and melanocytes, and these are going to recept or detect light touch. Okay, so they're receptors for light touch. Oops. So if you gently touch your arm, the Merkel cells are going to be detecting that sensation. Okay, now we move into our encapsulated receptors. So we have 4 encapsulated receptors. So we'll start, and keep in mind, right, the sensation of touch, all of these different receptors are being activated sometimes, right? It's not just going to be one or the other. They can work together as well. Okay, so starting with N bulbs or Krauss bulbs. Okay, so here, right, this is our first encapsulated receptor. Okay, so the terminal ending is just going to be wrapped in connective tissue. So if we have the ending, it's going to be wrapped up in protective connective tissue. Okay, so these are located in the dermis of the skin, and they're going to detect light pressure. Okay, so if you apply just light pressure onto your skin, right, we can get the sensation to activate the Krauss bulb or N bulb. Okay, so moving on to our next encapsulated receptor is the Pacinian corpuscle. Okay, and Pacinian is a big leaf or sort of onion-shaped tactile receptor that's going to be found deep down in the reticular layer of the dermis. So this is found deep to those Krauss bulbs that we were just looking at, or the N bulbs that we were just looking at. So these are going to sense deep pressure, right? So we would have to, and it makes sense that they're located deeper, so it needs more pressure to activate the Pacinian corpuscle. Okay, so deep pressure and also high frequency vibrations. Okay, in the soles of the hands and the palms of the feet, areas that are stimulated quite often with pressure, these are going to be located even deeper down in the hypodermis. Okay, so here in both these images, we can see our Pacinian corpuscle and over here. Okay, so deep pressure, high frequency vibration. And yes, it is encapsulated. Our third encapsulated receptor is the Ruffini corpuscle. Okay, and Ruffini corpuscle is going to detect distortion to the skin. Okay, so different to distortion of the hair, right? Because we can not even make contact with the skin and have distortion of the hair. Ruffini corpuscle, if we, right, move the skin or displace the skin, the Ruffini corpuscle is going to sense that or detect that sensation. Okay, so lastly, we look at the Meissner's corpuscle. So again, this is an encapsulated receptor. So you can look over here at this image and see how it's wrapped in this connective tissue. Okay, these are located in the dermal papilla. So remember those projections of the dermis that go up and interdigitate with the epidermis. Okay, so within these upward protrusions, we have the Meissner's corpuscle, and these are going to detect light touch. Okay, so be careful because there's another receptor that we looked at that detects light touch that also starts with an M, right? So the Merkel cell. But the difference is that the Meissner's is wrapped in connective tissue and the Merkel cell is unencapsulated. So this video is the only supplemental video on the week 9 to-do list. So please follow the only link under supplemental videos on your checklist and watch this video about tactile sensation.